All right, so here is our circuit review. We have a complex circuit here, and part A wants you to find the current through the 10 ohm resistor. So you'll notice, again, this is a complex circuit, so you have resistors that are wired in series and in parallel. Okay? In problems like this, you really want to start working from the inside out. So I'm going to start with this branch in the middle here, where I have 20 ohms and 30 ohms that is wired in series with one another. Before you even do that, let's just follow the path of the current here. Let's see what's going to happen. So remember, the small side of my battery is the negative side, long side is the positive. So current in this diagram is going to travel in a counterclockwise direction, go through the 10 ohm resistor, and at this point, this is a junction. So some of that current will decide to travel through the 30 ohm, the 20 ohm, and then come back out. The rest of that current will decide to go through the 100 ohm, right? And here's another junction where these two will meet and all of the current will go back to the battery. Okay. So again, let's start working from the inside out. So I'm going to deal with this branch in the middle first. This 30 ohm resistor and 20 ohm resistor are wired in series with one another. Right? So to work on part A here, I have 20 ohms plus 30 ohms, right? That gives me 50 ohms. And so now what I can do is just make a new sketch of what's going on. So I have my battery, I have my 10 ohm resistor out here. Right, that gets connected. Now I've just simplified this. So now I have a 50 ohm resistor here. And then of course I still have my 100 ohms up here. Sorry, it's a little crowded. Okay. And so looking at this, if you look at this, all of the current has to go through that 10 ohm, but again, I still have this junction here. And when you have a junction like that, that means things are wired in parallel. So my 50 ohm and my 100 ohm resistor, these are now wired in parallel with one another. So I can find the equivalent resistance between those. Right? And so to do that, I'm going to do 1 over 100 ohms plus 1 over 50 ohms is equal to 1 over REQ. And so solving for REQ, take the inverse of that. Oops. Gives me 33.33 ohms. Okay, and so again, if I simplify my circuit diagram here, right, I still have this 10 ohm down here, but I just found the equivalent resistance of that. So I essentially have 10 ohms and 33.33 ohms that are wired in series with one another now. So to find my total resistance, I'm just going to add these together. So 10 ohms plus 33.33 ohms gives me a total resistance of 43.33 ohms. So part A wanted me to find the current that is going to travel through the 10 ohm resistor. Now if you look at this diagram, it's a nice resistor that was chosen because all of the current is going to travel through that. So I'm going to use Ohm's law, V total equals I total times R total. Right, and so I know that the voltage is 12, my current is what we're looking for, and I know that my equivalent or total resistance is 43.33. So I get 12 divided by 43.33, a current of 0.28 amps. Okay, so that is my total current, and that is the current that's going to travel through that 10 ohm resistor. Okay. Part B wants to now find the total power consumption, right? So total power consumption of the whole circuit. So looking at the reference table, I know my power equation is P equals VI. And if I want total, I'm going to put total values in here. So P total equals V total times I total, which should be pretty straightforward here. So 12 volts times that total current that we just found gives me a total power of 12 times 0.28, 3.36 watts. Okay. And then part C is getting into the energy portion of this. Right? So remember, energy is equivalent to the work done. So on your reference table, you want to look for those work relationships. Right? And so this is W equals, we could do P times T. Right? So this wants how long. So we're looking for T here, and we want to produce 10 kilojoules of energy. So we have to convert that kilo to just joules, right? So this will be 10,000 joules equals the power, which we know this is capable of producing 3.36 watts, and we want to solve for T. So you get 2,976.19 seconds, right? And you can convert that to something that's a little more reasonable. So this will be approximately 49.6 minutes.